Okay, in our previous class, we discussed about rounding. We learned rounding to a required decimal place. Now, in this class, we have to learn about the significant figures. I will not go for the definition of significant figure at this level, and even you don't need that definition here. We should just know about the rules of the significant figures, because definition you will take in the physics also, and unless you understand the significant figures, will not be possible for you to understand the exact definition of the significant figure. So that's why first learn a few things about the significant figures, and then we may discuss the definition later on. Now, in my previous class, if you remember, we talked about that the number system that we are using, we call it decimal number system. Why we call it decimal number system? The word DECA stands for 10. As this number system is made of 10 digits, these 10 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Sorry, not 10, because 10 is made from 1 and 0. So every number in the number system that we are using in computer, we use other number system also. Okay, that's the binary number system, that is octet number system. There are so many different number systems that we use, but the number system at the moment that we are using is the decimal number system, and it has 10 digits. Every number that you will be made from these 10 digits. Any number that comes in your mind obviously is made from these 10 digits. Now, first thing that you have to remember is out of these 10 digits, these 9 digits are always significant. Wherever you will see them, you will say these are significant. Okay? So the rule number one is that about the significant figures that you have to remember is 1, 2, 3, 4, 5, 6, 7, 8, and 9 are always significant. Wherever you will see them, they will be significant. For example, if I write a number 237, now this number is made of 3 digits, and I ask you how many significant figures it has. So I will say 3 significant figures, because the first rule says that wherever these number digits will be, they will be significant. Okay. Now, which one is remaining? 0 is remaining. 0 can be significant, cannot be significant. Sometime it will be significant, sometime it will not be significant. So I will say 0 may or may not be significant. You can write these rules also along with me. So 0 may or may not be significant. Now obviously you will be thinking when it will be significant and when it will not be significant. Okay, so let's see. It can be significant, but before that you need to understand few things. Our 0 can be of 3 categories. Any number that you write, 0 can be at 3 different places. Okay. The first place can be, I can say, is trapping 0. The second can be leading 0. Your 0 can be leading 0. And the third thing can be 0 can be ending 0. Now, what is the meaning of these three things? Let me write an example here so your concept of trapping, leading, and ending 0 will be more clear. Let's suppose I'm writing a 503. In 503, you can see 0 is coming between 2 digits. If a 0 is between these digits any one of the any two of these, between any two of these, we will call it a trapping zero. Like here I will say 0 is trapping between the two digits. In this example, like this 0 is trapping, this 0 is trapping because it is between the two significant digits. It is between one of these digits, any of two of these digits. So I will say it is a trapping zero. Okay. Now leading zero. Leading means that comes in front of, like 0.007. These all are leading zero because they are coming before these digits. They are coming before these digits, so are leading zero. In the same way, if I write 0.00701, now these are leading. I will say these are leading, while this one is trapping. Why this one is trapping? Because it is coming between 7 and 1, so it is trapping. Okay. Now this one, in this case, these are leading. Why leading? Because coming before the main significant digits. In this case, this one is trapping. Why trapping? Because between 5 and 3, this is trapping, this is trapping. Clear? Now, next one is ending 0. Ending 0 is that comes at the end. Like these two zeros are ending 0 because they are coming at the end. In this case, this one is trapping, this one is ending. Why? Because this is between 1 and 7, so it is trapping, and this one is ending. I will say this one is ending, and this one is trapping because it is between, and this one is ending. Why ending? Because it is at the end of a number. All right. Now, let me take another example. 0.07010. Now, in this case, this one is leading, trapping, ending. So now if I write any digit, you will be able to know about the zero. Okay. Whether it is trapping, leading, and ending. Why I'm using these terms? Because it will be easy for you to remember. Again, before moving to the next step, you have to remember in our number system, all the numbers that we use are made of these 10 digits. Out of these 10 digits, these 9 digits are always significant. But 0 is controversial. 0 may be significant, may not be significant. Now to understand when it will be significant, when it will not be significant, we need to understand these definitions first. We need to understand these terms. We need to understand the trapping 0. We need to understand the leading 0. We need to understand the ending 0. Okay. So now remember, if you have a trapping 0, because we are saying 0 may be significant, may not be significant. Okay. Now, in the case, we have to decide now when it will be significant, when it will not be significant. So the rule number 3 says that if the 0 is trapping 0, is always significant. If the 0 is trapping, it will be significant. Always it will be significant. Okay. So this one is clear now. We have now two clear things about the significant. 1, 2, 3, 4, 5, 6, 7, 8, 9, wherever they will be significant. Okay. If the 0 is trapping, will be significant. For example, in this case, I can say significant, significant, significant. So there are three significant figures. In this case, clearly significant. Yes, Afif.
Sir, are you writing something on the board? Because it's not visible.
Why it's not visible? Oh, I'm sorry. I wrote, but I don't know why it stopped. Just give me 1 second.
Okay, sir, no problem.
Yeah. Thanks for reminding me that one. Let me, because if such thing happens, let me know, please. Okay, just give me 1 second, please. I'll stop sharing the screen for 1 second and we'll reshare back it. Still not? I'm writing but not appearing. Am I right?
Sir, it's like appearing slowly, like a letter after letter. Now it's okay.
You sure? Is it appearing to everyone?
No, sir, I think it's lagging. Sir, your writing, it's not appearing as you write it. Like
Yeah,
when
yeah,
you're writing,
I can feel that too.
yeah.
Just give me 1 second, please. Sorry. That now the trapping zero is always significant. Like in this case, I was saying in this case, we are having this 5 is obviously significant, 3 is significant, so 0 is trapping, so it is also significant. Similarly, in this case, this is significant, significant, so 0 is between them, so significant. This is also significant because it is between them, so significant. So I can say the total number of significant figures are 5. But about significant, I will come in detail. Just remember this rule. If you have a trapping 0, so the trapping 0 will always be significant. All right. Now the rule number 4 is about the leading 0. About the leading 0, remember, will never be significant. Leading 0 is never significant. Your leading 0 can never be significant. Like, let me write in this case 0.007. Now, about this one, we know is clearly significant. Yes, but these are leading. Being leading will not be significant. So I can say only one significant figure. Okay. I will bring the example, but right now remember this rule. Now, about we are now left with ending 0 only. About the ending 0, remember, ending 0 may be significant, may not be significant. Okay. Ending 0 may or may not be significant. Okay, you will be thinking when it will be significant, when it will not be significant. Before moving to that stuff, once again, I would like to recall so you don't remember. The rules will become easy for you. We started from here that the number system that we are using is made of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of these, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, they are always significant. Okay. Now, 0 can be significant, cannot be significant. But to understand that, we need to understand this definition. We need to understand about the trapping 0. We need to understand about the leading 0. We need to understand about the ending 0. But can you please hold on just for 1 second, please? I'm really sorry. Just hold on for 1 second. All right. So trapping 0, leading 0, and ending 0. Now, about the trapping will always be significant. Leading is never significant. Ending sometime will be significant, sometime will not be significant. Now, when it will be significant, let's write the rule number 6. According to rule number 6, ending 0, ending 0 in a whole number is not significant. Mean if the number don't have decimal, then the ending 0 will not be significant. But ending 0, ending 0 in decimal number is significant. If the ending 0 is in the decimal number, it will be significant. But if it is in the whole number, will not be significant. Now, before taking the examples, make sure at least 60-70% rules should be in your mind. I will keep recalling, but you will understand more better if these rules are in your mind. Okay? Let's take some examples. In example number 1, I'm writing in example number 2, example number 3, example number 4, example number 5, okay, example number 6, example number 7, 0.001030. Example number 8 is, okay, we have to decide how many significant figures are in each. Let's begin with the first one. In the first one, you don't have any zero. And if the digits without zero are always significant, so I can say 1, 2, 3, 4. There are 4 significant figures. For significant figure, I will shortly write SF. Okay, like for decimal place we write DP. So for significant figure, shortly I will always write SF. Now, in this case, in second example, we have to check how many significant figures are there. For that, let's have a look. Significant, 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 because non-zero digits are always significant. About the zero, this time zero is trapping. And we know if the zero is trapping, then it will be significant. So it means it is also significant. So how many significant? 4 significant figures. Now in this case, obviously significant, significant. But these zeros are leading zero. And leading zeros are not significant. So how many significant? Only 2 significant figures. Okay. Now in this case, significant, significant. 2. Okay, 0. This 0 is ending, but ending in a decimal. It's a decimal number and is ending. In the decimal number, endings are also significant. So it is significant. So I will say there are 3 significant figures. Okay. Now in number 5, significant. These are ending 0, but ending in a whole number because it's not a decimal number, and ending in a whole number are not significant. So only 1 significant figure. Okay. In this case, significant, significant, obviously because non-zero wherever are significant. Now this 0 is a trapping 0, so significant, but this one is ending 0 in a whole number, so not significant. So how many significant? 3 significant figures. Now in this example, significant, significant, these are leading 0. Leading 0 are never significant, so not significant. This one is trapping 0, so trapping 0 is significant. This one is ending 0, and this is a decimal number because decimal point is there visible. So also significant. So I will say there are 4 significant figures. Now in this case, non-zero, so significant, non-zero, significant. Now these are 0 and it's a whole number. 0 in a whole number are not significant. So I will say not significant. So how many significant figures? 2 significant figures. Hopefully with this example, your 80% concept should be clear. Let's take few more examples. Please make sure everybody understand that one.
Yes, sir.
Clear?
Yes, sir. It's clear.
Okay, all right. Now we'll write few more examples here. Please make sure you take your notebooks ready with you. Keep your notebooks ready and write. You have to write number of significant figures. First one is second one is third one, fourth one, okay. Your time starts now and let me know the number of significant figures in each one. In front of that, just write how many significant figures are there. So your time starts now.
Still done.
What about others?
Yes, sir. I'm done.
Okay. Time, Shadib, Muhammad, please make sure.
Sir, I didn't complete. I'm doing.
Yes, sir, I'm doing.
Okay, let's see. I will do now and you can compare your answers, please. Basira done? Marisha
Yes.
done? Okay. That's it. Yes, let's see. We have to write the number of significant figures, okay? This is significant. This is significant. Now, this is trapping zero, so significant. Ending zero in the whole number. So ending zero in the whole number are not significant. So how many significant are there? Only three significant figures. Hopefully everybody got that. Okay. Second one is leading zero, clearly not significant. Now non-zero, non-zero, non-zero significant. Zero but trapping significant. Ending zero, but this time it's a decimal number, so significant. So how many significant? 1, 2, 3, 4, 5, 6. So I will say 6 significant figures. Now this number 3, non-zero, significant. Okay, these are all zero. It's a decimal number. Decimal number. So can anybody tell me how many significant figures are there now? Will these zeros be significant or not? Anyone can.
It's 2 SF, I think.
This
The
is a
0
decimal
after
number.
the point.
In the decimal number, if the zeros are not leading, then anywhere else will be significant. So significant, 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 significant. So total number of significant are 5. Because are ending and it's decimal also. So that's why all will be significant. Okay. Now these are leading. Obviously leading cannot be significant. So these are not significant. Now this is non-zero, significant, significant. This is trapping zero, significant. So total 3 significant figures. Now in this case, non-zero, significant, 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 significant. Now these are ending zero, but it's a whole number, so not significant. So how many significant are? 1, 2, 3, 4, 5. So we will say 5 significant figures. Yes, Shafif.
Sir, could you re-explain the third example?
Yes. In the third example, if you remember the rule, I told you, if your number is a whole number, then ending zero will not be significant. But if it is decimal, if decimal is there visibly, then will be significant. Ending zero will be significant. Because it is decimal and are ending zero, so that is why we will keep them significant. Look at this rule. Once again, go through the rule. Ending zero in a whole number is not significant, but ending zero in a decimal is significant. So in this case, it's a decimal. If you look at this one, it's a decimal. Being decimal, I will say these are significant. Okay.
Okay, sir.
So now hopefully I can hope that if a number is given to you, you can count how many significant digits are there. Okay, let's move a step ahead. One more step, which is rounding to a required significant figure. A rounding to a required significant figure. Just like we rounded to required decimal place, this time we are going to rounding to required significant figure. Before understand how to round to required significant figure, one again make sure decimal places are something else. Significant figures are something else. For example, let me say I'm writing a 2.45. Now how many decimal places are in this one? Anyone can tell? How many? There are 2 decimal places. And how many significant figures are in this one?
3.
3 significant figures. So that's why never confuse the decimal places with significant figure. I can say 2 decimal places and 3 significant figures. In this case, we can say like 4,000. How many decimal places are? 0 decimal place. Because there is no decimal. Yes. So I can say 0 decimal place. And how many significant figure are?
1 SF.
1 significant figure is there. Because significant and non-zero are not significant. Okay, I'm writing now in this case, how many decimal places are? 3 decimal places. How many significant figures are? Non-zero, 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 significant. This is trapping, and obviously so will be significant. So total how many significant? 5 significant. So the purpose to give this example was to make sure you understand that significant figure is different than the decimal place. Previously, we learned the rules for rounding to a required decimal place. But now we are going to talk about the required significant figure. Okay, so let's see how we will do that. The rules will be same. For 0, 1, 2, 3, 4, no change. For 5, 6, 7, 8, 9, add 1. But when and where to add 1, let's see. I'm going to take an example. Now, if you look at this one, how many significant figures are there? Once again, I think the problem is I'm writing, but it's not appearing to you because I write another digit. Right now I'm writing, but it's not appearing. Just hold on a second.